This example is a little different. Now, one of the big problems with detached coefficient polynomial division is when the leading term is not monic. That is, that the leading terms are not 1. In this case, I'm going to choose an example. It's just the same as the other one, except I've made the leading term 7 in the dividend and 3 in the divisor. And I'm going to show you that this can still be done just fine with this method. Okay, so what we're going to do is we're multiplying. Where's my pen? Sorry, didn't mean to do that. We're dividing, 4f1 divided by 3f2, and we're going to set up our table. Things are going to be a little bit different, but not very much. Okay, I'm going to write down the terms of the dividend, 7, negative 91, 413, and negative 609. Then we're going to again write a roughly straight line. That should be a little bit longer than this line here. Sorry, I'm just trying to do this really fast. And then we're going to write down the terms negated of the divisor, 42, 15, and then now you see we're going to put a 3 down here, which is the leading term of the divisor. And just in a moment, it'll become obvious as to why. Now we're going to do things a little bit differently. The 7 does come down, but everything that we bring down, well, first of all, let's do this. The remainder is going to be the same. In other words, 3 minus 2 is still 1, so we know we're going to have a linear quotient. So there's going to be 2 terms here that are going to be the quotient, and the rest is going to be the remainder. Okay, that becomes more important here, because when we bring a term down, like we're bringing the 7 down here, we're going to divide it by the leading term in the divisor. So this becomes 7/3, what we put down here. In the remainder, we don't divide it. So when we get to that, it'll become clear. Okay, so then we got 15 times 7/3, which 15 times 7 is 70, 30 times, so we get a 35, I believe. It's nice, the number works out. So again, that's 15 across, 7/3 diagonally. 7/3 times 15 is 35. Then we come up with this one here, which again turns out to be a nice number because I set this up especially to be nice numbers, and it turns out to be the negative 7/3 times 42 is 98. Okay, then we can add up this column, and then we can continue making our partial products. Negative 91 and 35 is negative 56. However, again, like I said, if it's in the quotient, we have to divide it by 3, the leading term of the dividend. So we got negative 56/3. Then we multiply negative 56/3, going up to the diagonal to the right again, times 15, and again we get negative 280. Again, nice numbers only because I happen to choose them to be nice numbers. And then negative 56 times 42 is negative 784. And since we're up in the right hand corner of the box here, our table, we know we're done making our partial products. All we have to do is sum up 413, 98 minus 413 plus 98 minus 280, which equals 231. And then we need to sum up negative 609 plus negative 784, which is negative 1393. Okay. Now, I don't think I have time to complete, to multiply it out again to demonstrate to you that that is in fact correct. You can do that yourself, I imagine. Let me give you the resources for this. So if you are interested in it, I think it is at least as efficient as the traditional subtractive algorithm for polynomial division. You can look these up yourself. This is the original paper I found which explains it, generalization of synthetic division and a general theorem on the division of polynomials. And also in this book, Higher Algebra Sequence to Elementary Algebra for Schools, which you can find here at this link at Amazon. is great. You have to take both of these together to explain everything I did, particularly what I did in the second part. If you don't look at the second book here, the Higher Algebra Sequence, Elementary Algebra for Schools, you will not see, you'll probably not come up with any explanation for this adaptation here, which I found in the second reference. Hopefully that has been helpful to someone. If I made any mistakes, please somebody let me know. In any case, I better end it. It's probably getting close to 10 minutes.